Good morning or good afternoon, depending on where you're calling in from in the world, and welcome to our second installment of our Tobii Pro Lab tutorial series. Today we're discussing wearable eye tracking and analyzing and understanding Tobii Pro Glasses 3 recordings. This webinar will be recorded, so feel free to rewatch or share with students and colleagues. This is the second tutorial in this series that we have planned. We also hosted a tutorial about screen-based eye tracking with static stimuli last week. The recording for that tutorial can be found on our on-demand webinar hub. But for now, we will move on to today's agenda. Today, I will show you how quick and easy it is to set up a study in Tobii Pro Lab, our all-in-one software platform. We will be using recordings from Tobii Pro Glasses 3 wearable eye tracker. Finally, we'll dedicate the rest of the time for an interactive Q&A panel with my good colleagues, Karsten Gondorf, our Tobii Pro Lab product manager, and Thomas Gaudy, who's a product owner for Tobii Pro Lab. Throughout this entire session, please use the Q&A function in the GoToWebinar panel if you have questions, and we can address them during the Q&A portion. Though you might think that implementing eye tracking in your research is a daunting endeavor, I want to showcase that Tobii Pro Lab is fast to set up and very easy to use. Tobii Pro Lab will support your entire research workflow from start to finish, including study design, calibration, recording, as well as qualitative and quantitative analysis and data export without other tools needed. Tobii Pro Lab is flexible to a variety of testing situations. It's compatible with all of our hardware products. It helps enable free head movement and a comfortable testing experience for participants. And finally, you get quality data with metrics you can trust, great precision and accuracy, and a good history in this field with over 10,000 published articles citing our products and more every day. So now we'll get started showing you Tobii Pro Lab. This is the Tobii Pro Lab overview page. To start a new project, you can click one of these project types, give it a name, and see where it will be saved. There are 4 different project types. The screen-based project type is for use with our screen-based eye trackers, the Tobii Pro Spectrum, Tobii Pro Fusion, and Tobii Pro Nano, as well as our older systems. This is the type of project you'll use when your stimuli are presented on a computer monitor. We will not be using this project type today. The Glasses project type is for use with recordings from Glasses 2 or 3. This is what we will be using today. For reference, the Scene Camera project type is for use with non-standard configuration with real-world stimuli or a larger monitor. You will need a scene camera to record the scene if you're using real objects. This would be using a screen-based eye tracker, so we'll also not be talking about this today. The external presenter project type is when you're using another external stimulus presentation software, like ePrime 3.0. Tobii Pro Lab can co-acquire the stimuli and record the eye tracking data for easy analysis with our full complement of tools. Tobii Pro Lab is based on a license key, which can be activated or deactivated and potentially shared across different PCs. While Tobii Pro Lab can be downloaded on any computer, you can only use one instantiation at a time per license that you own. This is the license type. I have a perpetual Tobii Pro Lab license, and this is when my maintenance contract expires. Under the About and Update section, you can see what version you're running. This is important to confirm when you're collaborating or analyzing data, as data sets are not backwards compatible. This is also where you'll see if there are any updates available. At Help and Learn, you can find shortcuts, our user manual, FAQs, our Learning Center, and more. You can even learn more about our Tobii Pro onboarding program. But for now, we will open an existing project created with Tobii Pro Glasses 3 data. This is the project overview page for your Tobii Pro Lab project. For a little project background and rationale, this project is based on the 2011 paper by Marquardt et al. Called Nurses' Behavior and Visual Scanning Patterns May Reduce Patient Identification Errors. The background is that nurses are trained to verify patient information to ensure that medication is administered to the right patient. So they scan between different things like the patient's ID band, the patient chart, and the medication label. They look for the patient's name, date of birth, medical record number, medication, and the dosage. Nurses have been found to successfully intercept the majority of potential medication errors. According to a study by Leap et al., 1995, they actually intercept roughly 85% of potential medication errors. However, they're not always primed to identify such. And another study, Henneman et al., 2009, reported that 39% of nurses administered the medication to the wrong patient. Now, that's not to say that nurses are the cause of medication errors, because oftentimes external factors beyond their control are to blame, like interruptions, distractions, poor system UI design, inadequate staffing, or ineffective provider communication. So in this mock study, we focused on examining an internal factor that could mediate performance, visual scanning patterns. Namely, are certain patterns capable of predicting error recognition? The goal of this mock study is to establish a causal link between visual scanning patterns and error recognition that would have important implications for training. So the hypothesis is nurses who recognize errors will scan artifacts more efficiently. They will also have a longer duration of time spent looking at the artifacts and more frequent gaze transitions over the same period of time to compare single pieces of information across the artifacts. To facilitate behavioral coding and clear outcomes of this study, we want to follow specific behaviors to indicate error recognition. So in these videos that you'll see, if there's no error, the participant will push the IV stand towards the patient. If there is an error, the participant will set the IV stand on the floor. I want to give a special thanks to our friends at Research Collective, particularly Jordan, who is the patient in these videos, and Dr. Joseph Posek, who is the participant and has allowed us to use this project. Here on the project overview page, you will see all of the existing recordings. It shows the duration of each recording, as well as the date and time that each recording was recorded. You'll also see the percentage of gaze samples found. This is a nice metric to consider when you're excluding recordings from the final sample. You can set your own criteria for what that threshold should be. Next, we'll look at participant variables. You can see here we have several participant variables already set up, including gender, age, levels of formal education. You can add or edit participant variables by clicking on the plus button. Give it a name, and then identify which values you want under that participant variable. For instance, in this example, we wanted to add a variable on whether the participant decided to give the medicine in the final trial. Next, we'll go to the Participants tab. This is all the participants in the study. You can drop down and edit any of the participant variables for anyone here. This is all mock data, so everything was randomly assigned. Next, we have snapshots. I will tell you more about snapshots soon, but for now you can see that there are 9 different snapshots. It's very easy to add snapshots to your project. Click on the plus button and navigate to the folder. Finally, we'll look at the Events panel. You can create and log events to do custom analyses. Here we've identified the start of the trial and when the decision is made. So during the review of the recording, I'll go through and log all these events as I watch them occur. If you want to create more event types, simply click on the plus button and give it a name. The system will automatically populate a shortcut that you can use as you're reviewing the timeline for easy coding, but you can change that if you like. If you wanted to import more recordings, you could do so. I have a Tobii Pro Glasses 3 SD card plugged in to a USB port. Simply click on Import Glasses 3 Recordings, select your drive, and Tobii Pro Lab will automatically populate all of the available recordings on that SD drive. You can click on which recordings you want to import and click Import. For now, I've already imported all the recordings I want, so I'll hit Cancel. The next thing we'll do is review a recording and timeline. To find your recordings, you can see them here on the Project Overview page, but if you're not on the Project Overview page, click on the Analyze dropdown and you'll see the list of all the recordings. We'll look at recording number 1. The first thing you'll do when you get to your recording is replay it. There is sound associated with this video, but I've muted it here. You can also replay with the raw gaze data. In order to translate the gaze data from the recording to something more usable by researchers, we use what we call snapshots. Snapshots are a photo that you can create and upload. The benefits are you can aggregate all of the recordings from different participants onto one snapshot, and you only need to draw areas of interest once. Assisted map data is not perfect and will usually require a manual check, plus potential manual mapping, but it overall will save you a lot of time. To turn on the snapshots, click here under Show Snapshot. Here are snapshot images that we loaded earlier. If you wanted to add more now, you could click on the plus button. We recommend that you map the filtered data because it's faster, but you can also map the raw data as well. We recommend using the Tobii IVT attention filter if your participant is mobile, in this case they were, and they're wearing the Glasses 3. You can also use the Tobii IVT fixation filter if your subject is seated or if you're using a screen-based eye tracker. To start the mapping procedure, you will indicate which snapshot you want to map to, and then highlight the section of the recording that you want to run the mapping for. In this case, we'll pick Trial 1. Click and drag these yellow tabs to highlight the portion of the recording that you want to map. Right-click and click Run Assisted Mapping. The computer vision algorithm will then look for similarity between the recording and the snapshot for things like contrast and color. If you look up here on the top right, it shows that assisted mapping is running from recording 1 to patient chart for trial 1. Since I've already completed it, I'll close this. To deselect the segment of the recording, right-click and say Clear Selection. You can queue up the assisted mapping for multiple snapshots, and they'll all run in the background as well. Once the assisted mapping procedure is done, you can move on to the review and manual mapping. This is where you will step through frame by frame to check the points or add missing data by clicking on the snapshot. So here's how it works. You can see the fixation points as they have been mapped to this snapshot of the patient chart. Let's pause here. I'm going to use the arrows on my keyboard to move through frame by frame. This is an automatically mapped point, and it'll show you a similarity score as well. If you see an M, that's a manually mapped point. Actually, I might move that down here. You'll see here down in the recording that there are these green bars and some are orange. Green bars indicate points that were mapped to the snapshots with high confidence from the algorithm, and orange bars mean lower confidence and may indicate areas for manual review. You can also change the similarity threshold. If you want it to be higher, you can drag it up and you see that changed some of these bars to orange. Or if you're okay with a lower similarity, you can move it down. So this will help you indicate areas that may need a manual review. Some snapshot best practices we can recommend are that the snapshot should be as flat as possible. The more visually complex, the better, and it should be as close as possible to what the participant actually saw. We also recommend that you use digital copies of printed materials instead of taking photos. So in this case, we uploaded the JPEG of this patient chart instead of taking a photo of the printout on the clipboard. And then finally, we recommend that you run a pilot study and review the output to ensure that your data addresses your hypothesis. Great. Now we'll talk about event coding. I showed you the event types that I made earlier, but here's where you can log them. I have already done so on the timeline. So you can see trial 1 start, trial 1 decision, trial 2 start, and so on. If you wanted to create new events, you could do so here, just as we did earlier. And if you wanted to log them, simply navigate to the spot in the recording and either use the keyboard shortcut, in this case this is H, there it logged, or you can use the log event button right here. I'll delete these. You see it automatically adjusted the custom time of interest. I created these custom times of interest as the interval between the start of the trial and the decision to either administer the medication or not. To create a new custom time of interest, click on the plus button, but I'll show you how I did these. I used the start point as the custom event type trial 1 start and the end point as the custom event type trial 1 decision. There are lots of other events that you could use to create custom times of interest, but this was just relevant for this study. These intervals can be used in later data analysis. Next, we'll go on to more qualitative review in visualizations. You can find visualizations on the Analyze dropdown and click Visualizations. The first thing we'll find is a heat map. The heat maps are aggregated information about fixations over all the recordings. You can even select subsegments or by individual participant variables. You can change between count to duration. You can even change the opacity so you can see the stimuli underneath. The next type of visualization is a gaze plot. The gaze plots are individual recordings showing the order of fixations. In this case, every color is a separate recording or separate participant. The size indicates the duration of the fixation, so the larger the diameter of the circle, the longer the fixation. And they're also marked with the order that the fixation occurred. This will give you an insight into the way that the participants scanned these stimuli. One of our hypotheses is that nurses who recognize errors will scan these artifacts more efficiently. So we can start to understand that even qualitatively by looking at this data between the groups. There was a medical error in one of the documents for trial 3. So we indicated which participants found the error and chose not to administer the medication versus those who did not find the error and administered the medication incorrectly. These are the gaze plots for the participants who gave the medicine incorrectly in trial 3 compared to those who chose not to give the medication. You can see even qualitatively that there's a difference in where they were looking. The group who chose to give the medication incorrectly didn't have as many fixations to the patient name and date of birth, which is where the errors were. But for those who did not give the medication and found the error, they had more fixations to the patient name and date of birth. If you'd like, you can right-click and save these images to file to use in your presentations and journal articles. Next, we will go to the Area of Interest tool. You can find the AOI tool by clicking on the Analyze dropdown and clicking on AOI tool. When you get to the AOI tool, you can select one of your snapshot media and start to draw areas of interest. I've already done so, but I can show you how easy it is. Up here under Draw, you'll find 3 different shapes: polygon, ellipse, and rectangle. Simply click on the shape that you want and click to drag and draw an AOI. You can then move the AOI or resize it. You can also give it a name here. But since I've already created all the AOIs, I'll simply delete this. You can even copy by selecting the AOIs and clicking copy to paste then between the different snapshots. It's very helpful to do that to keep the AOIs between media the same size. We also have a feature called tag groups here at the bottom. Tag groups are a way to link AOIs across media. So for instance, I have a tag group called ID and tags called date of birth and name. So every time there is an AOI with a patient name, I can click the name tag group and analyze these across all the different media. Now these are static AOIs for our static snapshots, but sometimes your stimuli are simply not snapshot friendly. So we do have a way to draw dynamic areas of interest, depending on your paradigm and research questions. They do take more manual work than the assisted mapping tool, but it's possible. I'll quickly show you how that works. I use the same AOI tools to draw an area of interest. So you'll draw your AOI and then manually insert what we call keyframes to indicate the movement from one frame to the next. You can even turn on or turn off your AOI depending if the object is in the background or not. So you'll go frame by frame. The IV bag is not in the frame, so the AOI is turned off. Now when the IV bag is back in the frame, the AOI is turned back on. And then you simply move the AOI as the person moves their field of view. So you can see this is a little bit more time consuming, but it is possible to draw these dynamic areas of interest. Now we'll move on to the metrics visualization. You can find metrics visualization by clicking on the Analyze dropdown and clicking Metrics Visualizations. Great. Metrics visualizations will give you a quick overview of results and trends. This is a helpful tool, especially as you're piloting your data and you want to understand how your data looks before exporting it to do high-level statistics outside of Tobii Pro Lab. You can analyze things like total duration of an interval, which we have here. This interval was created, as I mentioned, by marking an event at the start of the trial and an event at the decision point and calculating the length of that interval. We have here grouped by condition and participant variable of trial 3 and whether they gave the medicine or not. Recall that giving the medicine was incorrect and means that they did not spot the error, and not giving the medicine was correct and then they did spot the error. So the total duration of the interval in seconds was shorter for those who did not spot the error and longer for those who did spot the error. This was our hypothesis, and the data supports this. Next, we'll look at the total duration of fixations, and the pattern remains the same. There were shorter total duration of fixations for the group who incorrectly gave the medicine as compared to the group who correctly did not give the medicine. This also supports our hypothesis. We can even look at number of fixations, and the pattern also remains. You can even look at other tag groups. In this case, if we wanted to compare the duration of fixations to the participant name versus date of birth, we can see that across the recordings, there were longer fixations toward the name, areas of interest, as compared to the date of birth. We can also look at more participant variables, like levels of formal education. Looks like there may be a slight increase in the total duration of fixations, depending on how much education you have. The next thing we'll do is go to the metrics selection and export. You can find metrics selection and export by clicking on the Analyze dropdown and clicking on Metrics. It's good to consider beforehand which metrics are most important. For example, you can find guidance through expert papers or articles from your field. However, these are the metrics groups that researchers commonly use. You'll see people report fixation duration, which is the total amount of time in seconds that the participant looks at an object, as well as the latency to fixate, so how long did it take for them to look at that object. Beyond duration, you can also find things like count, how many fixations occurred, or how many visits to an AOI occurred. You can also find event metrics, like number of events or interval between events, mouse clicks, or latency and count. We have saccade metrics, like amplitude, velocity, or count. We also have specialty reading metrics, like regressions and rereading durations, as well as pupil diameter outputs for left and right pupil estimates for each sample. So you can take that data and calculate offline changes over the time from the stimulus onset. We have a few different export formats that you can choose from depending on your needs. We have an interval-based TSV file, AOI-based TSV file, which we'll be exporting today, an event-based TSV file, as well as a high-level Excel report, which we'll also export today. I'll show you these in just a moment. Before you export, you can also decide how you want to filter your data. You can export the raw data by itself, but you can also use our IVT filters. If you click on the gear wheel, it'll show you more details about the values used to calculate for that filter. You can also create your own filters. Perhaps you work with special populations and you need to change the IVT classifier based on eye movements. That is possible here. Exporting the metrics is the last step from Tobii Pro Lab before the data is exported to then be imported into your favorite analysis software. But the last thing I'll show you is the data export. To find data export, click on the Analyze dropdown and click on Data Export. Great. The data export will give you all the XYZ data for each eye, for each sample, for the entire recording. Since our Tobii Pro Glasses 3 come in 50 Hz and 100 Hz sampling rates, that means you get a row of data every 10 or 20 milliseconds. So these can be quite long and large data sets. This is where you'll also find the pupil diameter estimates for left and right eyes for analysis in your favorite analytics software. You'll find the pupil diameters here. I'll show you what this data export looks like as well. Great. This is our Excel report. On the bottom tabs, you'll find each metric. I've clicked on interval duration because we were interested in the interval between the start of the trial and the decision. You can find all of that data here. Trial 1 interval for each recording. So it shows the total count as well as the averages. Now in this case, recordings 1 through 5 found the error and recordings 6 through 10 did not find the error. So you could do some analysis to see if there are group differences. You can also look at data for total fixation duration. And this gives you all of the attention to each AOI separately for each recording, as well as averages. Okay, this is the AOI-based TSV file. It's set up a little bit differently than the Excel file because this is easier to import into your favorite analytic software like SPSS. You see all the recording information is separated by row, also the AOIs, and then at the top you find all the metrics. Finally, this is the data export where we see all of the gaze data throughout the entire recording. This is a very long file with thousands of rows. You see here in column C, this is the sensor. So you see gyroscope, accelerometer, as well as eye tracker readings. You will see these two sensors alongside your eye tracker data. So if you see blank values, that's probably why. This is what the data will look like. And here are the pupil diameter columns. And that's it. And that's how simple it is to get started in Tobii Pro to import, inspect, and analyze your wearable eye tracking data with Tobii Pro Glasses 3. We envision Tobii Pro Lab as a productivity software. There's a job to be done, and here are the tools to make it happen. We hope this easy-to-use software helps solve your research problems. Obviously, there's always time to get accustomed to using any new software. But with this platform, we hope that there's a quick ramp up from learning how to use it to actually then collecting data and moving your research forward. I want to thank again our awesome partners at Research Collective for this great mock data set. They said that it is available to share, so if anyone is interested in playing around with this data a little bit more, just send us an email and we can get it to you. I also did want to share some helpful links we have here on the slide and showcase a very special event coming up from June 1st through 3rd. We're hosting an in-person 3-day course called A Practical Introduction to Eye Tracking. It will be at Lund University in Sweden, but it is in person. There will be a classroom full of our Tobii Pro Spectrum eye trackers and lots of demonstrations and opportunity to try both the Spectrums and our Tobii Pro Glasses 3. So you can find the link here to register for this course. So we hope if you're available that you can check it out. Another of the few links we have up here, if you want to try Tobii Pro Lab for yourself, you can download a demo for 30 days absolutely for free. So you can click on this link and click on sign up for a free trial and get a free demo license. We also have demo projects available. And like I said, if you contact us, we can send you this one as well. So you can test it out and try some of these techniques that we discussed today with automatic mapping and analyzing all the data. If you are working on a grant proposal to acquire funding to buy a Tobii Pro system, we want to help. This is a complimentary service we offer called Tobii Pro Funding Support Services. So if you want to get in touch with us about supporting your grant proposal to help you be more competitive, you can contact us at tobiipro.com/FSS. If you are an existing customer and you have questions about your Tobii Pro system, you can always reach out to our customer care team at connect.tobiipro.com. And if you are a prospective customer or don't have a system yet, but want to talk to someone from our sales team to get some pricing or some other specifications or answer questions that we didn't get to today, you can contact our sales team at tobiipro.com/contact. And finally, if you want to watch more webinars like this, including the one we hosted last week with screen-based eye tracking with static stimuli, the on-demand webinar hub is listed there too. So before we get started with your questions, we have a couple of quick poll questions for you to get to know our audience a little bit. So let me get those going. The first question is, have you used wearable eye tracking in your research before? A couple different answers. Yes, you're using it currently. no, you haven't used wearable eye tracking, but you have used other types of eye tracking, and then no, not yet to both of those. Looks like we have quite a lot of people who are potentially using it right now. Just give another second. Okay. Okay, great. Let me show you the results to that. Looks like actually most people here are currently using wearable eye tracking, so that's really awesome. Some have used other types of eye tracking, and some of you have not used any eye tracking yet, but we hope to be able to help you in the future if it's on your to-do list. So let's look at the other question. We want to know, what topics would you like to learn more about? This is an ongoing webinar series. So last week, again, we talked about screen-based eye tracking and static stimuli. Today we're talking about wearable eye tracking, but there are lots of other things that we could show you. Are you interested in stimulus presentation and design tools we have in Tobii Pro Lab? There are lots of different tools we have to show web stimuli, video stimuli. We could do screen recordings. We can work with ePrime. More tips about calibration and recording, including in Glasses 3, which I know we didn't show today, or more data analysis. So let us know which topics you want to learn about next, and you can check as many as you want. Okay, looks like we got a lot of answers here. So let's share. Looks like many of you want to learn more about stimulus presentation, some people about calibration, but a lot of people want to learn more about data analysis. So we would definitely keep that in mind as we're planning for the future, and we hope that you come back and join us again for our next webinars, especially if it's about data analysis. We'll keep you in the loop. So now I want to invite my colleagues Karsten and Thomas to come back so we can start with your questions. We have had some good questions so far in the chat. You can keep asking them as well. We'll get to them as they come in. For now, I did want to ask, someone wondered, how is data collected? What is the software used? And what are the things possible? I did not showcase the Tobii Pro Glasses 3 controller, but that's the software that you use to do recordings of the Glasses 3. You can watch live as people are going through their task. You can watch exactly where they're looking in real time. So Tobii Pro Glasses 3 controller is the software that we used to do these recordings. Here's a good question. What value would you recommend for the similarity threshold when doing the automatic mapping? I don't know if one of you wants to give some advice on that.
Yes. I mean, for the values there you would choose, it will of course depend a bit on what you're doing, but generally speaking, we would recommend around 70. So it's like 0.7 or 70% for the similitude value. Most of the points that you will see we have a higher value than 70 will be actually accurately mapped. So that's that would be our recommendation for a value there.
Awesome. Okay, we had a question here, very interesting one. So they had a question about date and time in the recording overview. They are anonymizing the recordings to a random recording so that students don't recognize recordings. Considering GDPR rules, is there any way that the time and date can be deleted in the overview or masked somehow? Or what would you recommend?
So they cannot be deleted from the overview directly. I mean, once you have imported those recordings, they will show there, so there's no possibility to change it. But one thing that is always possible, at your own risk, of course, but the recordings you have from the Glasses 3, they contain a metadata file that is called recording.g3 inside the recordings folder, and inside there is the actual date that we use for this field. So you could also change that date, to be the same date for all the recordings if you wanted to. Of course, be careful with that. Always back up those recordings. Don't just edit the original ones. Make a copy of them. Try to edit there, import it, see if it works well. That would be one way if you really want to get read of the date from the data. It will still show in Tobii Pro Lab once you import it afterwards, but then you can have a a random date like 1st of January 2021 or whatever that would be.
And perhaps one add-on here is I think it would be good to connect to our support staff before doing this kind of manual operations on the meta database. Would always good to check with them firsthand. And if you like the submitter, if we could check in after the meeting on your GDPR questions, I would happy to learn more about them. So please write in the chat if you would be available for that.
Awesome. Thank you both. Yeah, Marianne, if you have follow-up questions, please feel free to get in contact. We can get the question to Carsten and Thomas and help you get this sorted. Great. Another question from Tim. Is there more specific information available on how the computer vision algorithm for the assisted mapping tool processes the scene? So I'd love to hear more about how that works.
Yes, so that's a question we often get. The algorithm per se is not so it's not described, it's not published in any way, so we don't have like extensive documentation around it. But I mean, we have general comments around what it does. So it is a computer vision algorithm. It works with local features in the scene camera video of the glasses pre-recording, using local features from there and trying to match them to the local features in the snapshot that you're using. So there's lots of things that go into considerations, of course, colors, edges, specific shapes that are considered. But we don't have like a documentation that we can refer you to that would be a bit more extensive. So it's more generic, I would say, explanation of what it does. I hope it does answer the question a bit, at least.
And I guess we're limited in the things that we can share with the algorithm. Great. I hope that you understand that, Tim. Okay, let's see. Great question here. How much time does it take for the assisted mapping procedure to work? So, for example, I think I highlighted about a 40 seconds worth of this recording, and the question is, how long does it take to map that in the background? I've heard some numbers thrown out, but I'd love to hear from you two.
Maybe I can answer that one too.
Yeah.
So typically, of course, it will depend on the machine you're using, and you might have a very slow computer, you might have a very fast computer, but say on a recommended machine, we see that around a second of recording will take about a second to map. So if you had more recent machines, say from the past 5 years, rather like a medium to high range computer, then about 1 second of recording for the 1 second of mapping.
Yeah, and I think if you check the system recommendations on the Tobii Pro product page for Tobii Pro Lab, we have them linked there if you want to double check. And of course, always our Connect portal support is open for every questions and yeah, additional information on that.
Awesome. Great. Another question, is it possible to download all the raw data at once? That wasn't possible a year ago. Talk about, I guess, some of the data output, a little bit more detail.
I don't think we touched that in the last series. So I thought, I mean, it's possible to download or export, process, and raw eye tracking data. And then we need to zoom in a little bit to that question. What was the blocker? I think. Otherwise, Thomas, do you have any?
If you could elaborate exactly what you mean by raw data, because I mean, in the data export that Marisa showed there, you can export all of the data for all the recordings, and that's all the raw data. You get eye tracking data from the Tobii Pro Glasses tree. So it would be great if you could tell us what do you mean by raw data? Is that the videos, or is it more like the actual eye tracking data, the numbers?
Yeah.
So it should have been possible to do that 1 year ago as well. So short answer, but yeah. Let's circle back on that one.
That's right. Yeah. So Clemence, if you have clarification for that question, feel free to let us know. Otherwise, if you're talking about the eye tracking data, it is in the data export. If you're looking about the time series data, that's the very last thing that I showed, was exporting all of the XYZ data, and then it shows up as this big Excel sheet that you can see all of the gaze direction and fixation points for both eyes separately. Okay. Question about the 3D gaze vector data that the Glasses 3 provides. Is it possible to visualize those in Pro Lab?
No, it's not.
It would be interesting to know what you're trying to do by visualizing those. There are some solution. I don't know if we have integration yet with the Glasses 3, but we had integration with Glasses 2 before with the eye motion capture, with the capture system, Qualitative. Yeah. So you could see in 3D the scene with the head of the participant and where they're looking with the gaze vector. But that's a different software than Pro Lab.
Yeah.
Yeah. Okay. Okay, we got a follow-up from Clemence. It's about the videos and recordings. We tested the software a year ago, and we had to download each recording by itself. And it was time-consuming. So I guess the recording with the gaze overlay.
Mm. Yeah, so it's still the same case. We haven't changed that, so you would still have to select individual recordings to export with the video and the gaze overlay. Yes.
Yeah, but we added something in the controller, like a video mode. So if you're only interested in the overlay, so there's a new mode that you can choose when you're starting G3 in the controller, something like a video mode. It's a burned-in gaze point that you can just download directly from that application. So you don't have to go into Pro Lab to do this, only for further analysis and chopping of your project and recordings data.
If you do that, those recordings are not compatible with Pro Lab, is that right?
That's correct, yes.
Okay. Okay, so it sounds like there is a way to more easily download those recordings with the gaze overlay by selecting that option in Glasses 3 controller, but then those recordings would not be compatible with Tobii Pro Lab. So if you're an existing customer, just keep that in mind. There is still a way, obviously, to highlight the section of the recording and export that with the gaze overlay from Pro Lab. But as you are mentioning, that if you're doing that for all the recordings, it is going to be a manual process. So yeah, if you have more questions, feel free to reach out to us or contact the customer care team to maybe try to help you out. Thank you so much. Okay, how would you suggest to analyze dynamic stimuli in something like a mobile app?
Maybe, I mean, it depends. I think what would be good is to consider what kind of restraints you want to have in your design. Do you want to have a free to move participants, or do you want to, do you have more of a lab kind of setting? So you have a participant coming into a lab. If you have a participant coming into a lab, we have solutions inside Pro Lab that don't use the glasses at all. So what we would call a scene camera setup. So you could record a screen from a mobile phone and get that into Pro Lab and the gaze data overlaid on top of it, so you could analyze it directly there. So that would be easier than using the glasses. Of course, if you want to have more of a, if you're striving for more natural settings where your participant is maybe in a context where there's other screens around, or wouldn't depend on what exactly you're interested in, but then if you're interested in that interaction, not only on the mobile phone, but for other things, then we would recommend the glasses for multi-screen scenarios, for example. So it will depend a little bit, but there's both ways are possible. It's always good to try to avoid using glasses if possible, as it's more complicated when it comes to the data analysis. So try to be as restrictive if you can as possible. Even have a mobile app tested on the laptop screen with a screen-based eye tracker is also an option. Of course, you won't have the natural interaction of a touch screen, but that's also a possibility. So you need to really see what exactly you're interested in your design, and then have an experiment that's built so you can answer your question. And then you need to trade off on how natural that will be for the participants.
Yeah, that's a great answer. I have done some quick demos of looking at my phone while I'm wearing the glasses and walking around a space. And if you take a snapshot of your phone screen, I have an iPhone, the software, I can do the mapping procedure to a snapshot of the background. And if you have somebody using an app and page might look different here or there, you're going to find some times where the mapping doesn't translate to the snapshot, but you could have a lot of different snapshots. So if you really wanted to have the participant in a natural environment using their mobile device, you can do snapshots and do what we did today. But I think Thomas' points of controlling the situation are really important, and realize, are you really looking for the UI or the UX design aspect, or are you looking for how the person uses this as they're kind of going about the rest of their life? So those are really important points to consider. Awesome. Okay. We got a follow-up question about the 3D gaze vectors from Tim. So the question related to 3D gaze vectors, because the integration with Qualitative is not out yet, and I would like to assert how accurate the 3D gaze vector is. I tried to understand the data export from Pro Lab, but is in the HUCS coordinate system.
Yes.
Yeah, so tell us a little bit more about that.
So I'm surprised. I mean, there's a small drawing there on in Tobii Pro Lab user manual, actually describing what this HUCS is. So it's the head unit coordinate system, the acronym for that, and it's basically a coordinate system that is fixated to the head unit of the glasses. So that's the actual glasses, and this is centered on the scene camera. So the camera you have in the front of the frame here. So you can try it out. You get X, Y, Z coordinates for the different directions. So I think X is to the left of the glasses, Y is going downwards, and Z is going in front. So yeah, that would be the actual coordinate system. So yeah, okay. So I see you answered that the UCS. So it's the same. I think that would be the same coordinate system, if I'm not wrong. I will need to check that exactly. So that would be the documentation from the glasses.
And that's in the appendix, right?
Yes.
Yeah. So for anybody else who's interested in the head unit coordinate system, that information is in the appendix of the Tobii Pro Lab user manual. You can find that on the Tobii Pro Lab page, or if you Google Tobii Pro user manual, which I do all the time, it'll take you right to it, and you can look in the appendix or the appendices, because there are several different coordinate systems that are explained for the data. Awesome. Okay. We have a question from Jukrin. Hi, Jukrin. Can you share the list of related literature related to eye tracking data analysis? So we do have, we had a Zotero database. I think we're working on updating our database of literature. I can send you the one that we have. Is there something else that's more updated on our website that either of you know about right now?
No, it's in flux, so there's no updates. I think the course that you mentioned in Lund would be perfect for data analysis. So if you have time and can travel there, so sign up.
Yeah.
That's cool.
Otherwise, Jukrin, I can email you that Zotero link or whatever I have available after today. Cool. We've been in touch. She was actually at the webinar I hosted in March in person at the HFES conference, where we talked about this data set. Okay, are dynamic snapshots absolutely necessary and better than the static photos of the targeted objects in assisted mapping? So I guess, yeah, comparing this assisted mapping procedure to dynamic AOIs.
Yeah, so I guess there was a little bit of confusion maybe there. So the snapshots that you add are, so they're always static. I mean, that's an image. And that would be interesting in all the cases where you have a stimulus or a scene or stimulus scene basically that your participant is exposed to, that is the same across all your participants and recordings. Then it's very easy to aggregate on it because you can have one image of it, and like in the case that Marisa was showing there. But if you have, in some cases, you might not have that. Maybe it's a very, very dynamic scenario that you have. I'm thinking, for example, someone playing golf, and you're interested in, well, are they following the golf ball with their eyes or not? Then in that case, a scenario with a snapshot like that would not work well with assisted mapping or any kind of mapping. So you might want to in that case, use those moving AOIs. It's a bit more tedious because you will have to go recording by recording and do the analysis, frame by frame, moving the area of interest frame by frame. So that can take some time. So I think it varies, depends based on what design you have in your experiment. And
the more dynamic the content, the less successful the assisted mapping will be, I guess, right? We can say that.
Exactly.
Right. Yeah.
But you always have the manual fallback solution that you can map like manually, basically. So it's always a good option.
Right. But no, it's not necessary to do both. I was just trying to show very briefly how you could do it. I think we could spend an entire webinar just going into the specifics of dynamic AOI design and probably even snapshot mapping too. But there are two separate things for two separate purposes. So definitely not necessary to do the dynamic AOI analysis. If you have snapshots, we highly recommend using snapshots. Or for those things that can't be snapshotted, not snapshotable, then the dynamic option is there. Awesome. I think I got all the questions that are currently in the chat box. If anybody has any last minute questions, please feel free to throw them in. I also wanted to quickly say, it did seem like there were a couple people who had some technical issues at the beginning, but if any of you are watching this on the replay, we are going to be hosting another few sessions with Carson and Thomas. I think that being able to ask the people who are designing the software questions directly is super cool, especially if you're already an existing customer. So having this platform is great, and we so appreciate both of you being here. So if you're watching this as a replay and want to join again in the future and ask them some questions, please feel free to do so. We have a couple more dates. I think it's June 8th and June 15th, and the signups for those webinars will be on our events page on our website. Okay, Tim has another question. I want to use the eye tracking data in a
human-robot interaction scenario.
Okay, great.
I just read the question, so I mean, we don't have support for like robot operating system, but if you could use the API that comes with the glasses. So there's no, it's an API, so there's no, as long as you have a language there that supports like HTTP and the rest, you will be able to work with the API and ask the data directly to the glasses and stream them to your to the robot, so you can make decisions there if you want. So that's definitely something you can do. I think the challenge there will be mostly how to interpret the data, but I leave that up to you. I think so. That's a interesting but tricky thing to do. Yeah.
But I think Tim has a little bit more complex from use case here. I think if you sum that up for us and then put that in the support portal, we try to catch up on that and then see how we can get to a solution together. There was an API and Qualitative webinar, I think earlier this year. And when we released the Glasses 3, there was a webinar around the API. I think we have that on our website somewhere where available. So it should be, not sure if it's easy to find, but should be able to find, but we can link to that as well, Tim.
Yes, if you Google Tobii Pro API, Tobii Pro Glasses 3 API, the webinar is at the bottom of that page. I Google things all the time. I mean, I'm sure I can navigate on our own page, but Google is so helpful. Okay, last questions. Is there an eye image recording function in the plan for Glasses 3 and Glasses 3 controller? Can we answer that?
I think it's under discussion, I would say. I don't know if it's in the plan, but it's being discussed. So you will get more information regarding that, I guess, in the near future, I hope. So yes. Not much we can share at the moment.
Yeah, it's definitely, we are aware, and yeah. But yeah, keep in touch. If you are an existing customer with Glasses 2 and waiting to upgrade, please keep in touch with us. I think that's important.
Perhaps also, well, I mean, if you like to add what you like to use it for, that would be also interesting. What you like to, what your insights you like to get from that.
Yes, the R&D teams do really like to hear customer use cases when they're trying to decide between, how to move forward in planning. So whatever details you can provide, you can send it here. You can send us a message afterwards with a little bit more details on what you would use the Glasses 3 eye images for. So yeah, let us know. Keep in touch. If there are no more other questions at this point, we will wrap up and say thank you so much to Carsten and Thomas. Thank you so much for being here today. If you are existing customers, you have questions, contact us at connect.portal, connect.tobiipro.com. If you're a prospective customer, tobiipro.com/contact. And we would love to chat with you more. And hope you have a great rest of your day.
Thank you, everyone.
Thank you.
Thanks, Marissa. Thanks everyone.